Thanks, Justin. Yeah, my name is Leigh Capili. I actually grew up here in the LA area, Glendale, Eagle Rock, etc. I don't know if any of you guys are all from there. Yeah. Who drove here? Yeah. Everybody drove here. So we got a bunch of locals, all right? Yeah, we all live here. So this used to be my house, but this is your house. I'm glad to be back home. I used to work on the Kubernetes project quite a lot upstream. Now I'm still involved, but more involved with the Flux project, which is about doing GitOps and how we use Kubernetes as a team together, right? And I am Filipino-American. Any Filipino Pinoy people over here in the house? Yeah? Hey, what's up? What's up? Cool. Yeah, little known fact, the Tagalog is the third most spoken language in California. So that's what we speak in the northern Philippines. Yeah, I work for VMware. I have a VMware shirt under this hoodie from a previous employer. So, but is my clicker working? I need to turn this thing on. Sorry, man. All right. So I got a story for you. You know, I used to be just a developer before I discovered the curse of infrastructure. Right? I was always like on my terminal, right? So I'm at my keyboard. I'm rolling in. It's Wednesday. I'm finding my groove. I got my bubble tea. And then sit back, deploy apps, shipping. Trying to update on hump day, but now I need a new play because the app's on fire. This is so not dope. I can't debug. My team is losing hope. Because I just clicked the button, it wasn't disabled. I was on cloud 9 and then it dropped the table. Big surprise, just a simple reflex. Now production's down and I need some Kleenex. It was a wall of text, needed some glasses. We on Kubernetes, but the app still crashes. I was doing work, I got a cert. I took some classes, but I can't help now because I don't got access. Just click the button, it wasn't disabled. I was on cloud 9 and then it dropped the table. A big surprise, it's a simple reflex. Production's down and I need some Kleenex. Walls of text, I need some glasses. We on Kubernetes, but the app still crashes. I did the work, got the certs, took the classes. I want to help now. Could I get some access? Right? What's the deal with that? I'm trying to update the app. We lost all our data because, you know, some stuff happens sometimes. So how many of y'all been in a situation where you're working with your team, right? It doesn't matter if it's a system or a meat locker. You are at work, you're trying to like pour somebody coffee, you're trying to go and send somebody some files, you're trying to open an email, and then you didn't have access to some information, some file, some place that you needed to make a critical decision. But you knew what you were doing, right? You needed somebody who previously had access to that thing to trust you, to delegate to you, to give you the ability to do your job so that you could all do what you were trying to do together. And so today we're going to be talking. We're going to start with like a lot of 101 content, right? Like just deduce from the very basics. And then we'll get into some advanced stuff. Who here is like a Kubernetes advanced user, right? Like they are running things. Okay, right? So not everyone, right? But I got to tell you, I was reviewing these slides even just this morning, and I learned something. And I helped like build a lot of this stuff, right? So if you just got one computer, you're not sharing it with a lot of people. But say you open up your laptop and you put your fingerprint on there, or it like scans your face now because this is 2023 and everything is terrible. The laptop wants to know who you are before it actually gives you access to the place that you need to do your work, right? And maybe it's just you, or maybe you also have like a login for your cousin or something. When you got a data center of computers or a distributed computer like Kubernetes, we're talking about using a lot more physical resources, a lot more. We are carving out a bigger space in the world. And it's because we're intentionally trying to share the distributed computer with a bunch of people so that we can deliver a lot of value or kind of make something entertaining or transform information in a cool way with our cool app or just be really good at capitalism, right? And so this distributed computer, it allows us to do all of these cool things in a bunch of different domains, right? Kubernetes can deploy apps for us. Some people might be interested in that. It can also set up networks. I can tell you before, when I was starting out as a software engineer, like I had no business setting up networks, but there was a network engineer somewhere who set up my networks for me, right? Kubernetes, even though it's a big distributed computer, it has APIs that allow you to manage lots of servers. It allows you to enforce policies. And each one of these cool capabilities that Kubernetes as a distributed computer has gets split up into APIs with these resources. Right? So the deployments is part of the apps API. You got services, which are part of the networks API. Nodes has its own API. The network policy has its own API. And it maps up, right? You can make these objects. Kubernetes has this declarative programming model where like the programs we write for Kubernetes are these declarative YAML files. That's how you tell the computer what to do. And they're split up into API groups. So even though you might have just been working on an app with one API, Kubernetes has lots of them that all have the same shape and structure. And so you can do so many things with this computer. And often what we find ourselves in is we have one of these or maybe multiple Kubernetes computers. And we have entire communities, almost like an entire city of people. Maybe a town. It's a town of people who are all interested in using parts of it, right? Some people want to deploy apps, some people want to set up networks, some people want to enforce policies, some people want to manage, like groups of computers. Other people want to change the way that releases happen and all kinds of stuff. And so we all want to grab a part of this. And the API that lets us dole out and delegate and split up the pieces and functions of the computer to the people who need to be able to do their job is called Role-Based Access Control, or RBAC. If you ever hear people talking about RBAC, now you have been enlightened with the jargon. So when we log into a computer, it needs to know who we are, and once it knows who we are, then it's going to give us the access to the thing that we want, right? And so this is split up into two pieces, more jargon here. Authentication and authorization. There's an N inside of the authn, and then there's a Z inside of the authz. So if you ever read like some security marketing thing for some product that you shouldn't buy, sometimes they say like authn and authz. This is what they're talking about. Right? They're talking about login, and then they're talking about granting access. So, but if we've got authorization and this role-based access control API, where did the authentication part go, right? If role-based access control is an authorization API, then you can say what people and apps are able to access, but that doesn't really answer the authentication part. So kind of said this backwards. This is not for authentication, right? So RBAC, it does not handle the login part of Kubernetes. It's only about controlling what we have access to, not concerned with figuring out who we are. There's other mechanisms for that. And that's just a clear distinction before we get into things. So now I want to look a little bit about the structure. Okay, well, if this is so important, if this API is the thing that lets us control how we share and split up this big distributed resource that's important to delivering our company's mission or our group's, whatever, shipping software, then we want to break down the structure. How do we actually use this API? I think a lot of times if we are a Kubernetes user, we kind of end up accidentally just grabbing for things when we need them. But with something as important as how we work all together, we got to know the basics. Let's learn the principles. If we want to target people or apps, the generic word for robots or people in Kubernetes is called a subject. It's kind of like grammatical, like there's a subject of a sentence, not the verb or the noun, or the target or whatever. So subjects then gets split up. There's people. These people are called users and groups. Right? So the most basic unit of a single person that the RBAC API needs to authorize, be giving access to, is called a user. And then you can group them up together. These two objects, if you've ever used Kubernetes, you'll know that you can like create objects, and we often capitalize them like this. They are not resources that you can actually put into a cluster. They come from Kubernetes authentication system and integration. So we just target them. We don't ever make users or groups inside of Kubernetes. They always come from somewhere else. That's a little bit different for apps. So when we talk about applications, or the robots or programs or routines that we put to actually tell Kubernetes what to do, those things can be given an identity by something called a service account. And a service account is actually a real resource that you can create inside of Kubernetes. So Kubernetes has an authentication system inside of it that maps service accounts to these special users. The way that this works is like, just technical details. It doesn't really matter how this happens, but you put a service account inside of a namespace, which is kind of like a folder. And when you have a running application that gets that service account tied to it, then Kubernetes will give each pod of that application a specific token. And then that token like lets Kubernetes know what that application is so that it can grant it access through the RBAC API. So this used to work a different way. We're not going to talk about that way because we deprecated it recently. So just this is how it works now. So now we have our subjects, right? This is the who of who has access to what. For people, we have users and groups. And then for apps, we got service accounts. The users and group come from some sort of authentication system that's outside of the RBAC API, and the apps have an internal authentication system that gives them service accounts. And who has access? So we only have part of this question. And then access to what? The way that we start answering the rest of this sentence is with a different object called roles. So roles allow us to describe what should be accessed, right? It's the noun of the sentence. And roles have rules that list which resources and what verbs you should have in that role, right? So if you can view a bunch of things, you might have a viewer role. If you can edit a bunch of things, then you might have an editor role. And the bunch of things can be as specific or as general as you want. I can hop into a Kubernetes cluster actually and just show you what one of these looks like. So this is the default view role from a kind cluster, similar to like if you saw the previous presentation. Caslin and Christina's demo had a kind cluster. You just make a cluster. It will, by default, have this view cluster role in it, and there's a list of rules. And that rule has a group for which API all of these resources are in, and then there are verbs. So anybody who might have this role view would then be able to go and do all of these things, whether that is a person or an application, right? All right, it's just a little bit of structure. So we list the allowed APIs. Roles themselves will live in a namespace. Roles can only list namespaceable resources. But there's a different object that I was just showing you called a cluster role. And a cluster role is capable of listing namespaced resources, but it's also capable of listing cluster scoped resources. We talked about how namespaces are similar to folders, so I drew you this picture. And there's not a, you don't need to worry about the colors and boxes, right? But you can see we have different types of resources that live in namespaces. The namespaces are these yellow boxes, if you can see yellow. And then at the blue box on the outside, the cluster scope, we can put cluster scoped resources there. So roles only can describe access to things that live in these folders or these namespaces. But cluster roles can describe everything. Now, I'm trying to be very careful about describing how these things just point to verbs on these resources, because no access is being granted yet. For that, we need another object, right? So we have who and we have what, right? Whether your subject is a user, a group, or a service account, whether your role is a role or a cluster role, we can describe some app or some person, and then we can describe some resources in some folders somewhere across the cluster, whether they are in namespaces or not. But then there's this object called the role binding that ties these two things together, right? And so now we have role bindings, which can then take subjects and give them some role. And so this is how you have the whole question. Hopefully this is making sense. Just nod like if you're kind of following along, because we're building up. We're going to start talking about some a little bit more tweaky stuff. So this allows us to answer the whole question. Who has access to what? Well, the RBAC API allows us to authorize a subject to have access to a role's rules. And now we kind of get a little tricky. Role bindings are also a namespaced object. So you role bind within a namespace. If you want to role bind across the cluster for every namespace and at the cluster scope, you have to use a cluster role binding. So say you do a role binding with a role. These things are going to both be in the same namespace, and they're going to grant access to resources within that namespace. It could be to a person or an app anywhere in the cluster. A cluster role binding can only be used with a cluster role. Right? So you can't cluster role bind to a role in some namespace, because that wouldn't make a lot of sense. You got to do it across the entire cluster anytime you're doing a cluster role binding, and that's how you can do cluster scope stuff. But there are some misconceptions. So we have this API. It looks like this, right? You have some subject. That could be a person, an app, or anything inside, outside the cluster. Role bindings go to roles. Makes sense. Cluster role bindings go to cluster roles. Makes sense. This is something that a lot of people, even if you're a Kubernetes expert, completely gloss over, which is that you can role bind to a cluster role. And when you do this, you unlock a really powerful pattern. It is the privilege of not repeating yourself 50 times. Say you're managing 50 namespaces. You want to give a similar amount of access to verbs on resources in all of those namespaces, but to a bunch of different people. You don't need to redefine the role every single time. You can have the role at the cluster level, but then role bind from only the namespaces where you want those access controls to be opened up. And so what happens here if the cluster role actually describes cluster resources is they just get ignored. And you wouldn't really describe cluster resources if you wanted to do this. But this is the misconception number one. If you just learned about RBAC today, congratulations. You know more than most Kubernetes practitioners about RBAC now. I've done the survey over many years. Like, this constantly surprises people, and it's because the names just, they seem like they would match up, but you can also do this. And you almost always want to do this. So, this is a beautiful picture that I'm so proud of, because this is another misconception. Some people would think, oh, this is like a one-to-one-to-one mapping all the time. But if we are trying to get the principle of least privilege, when you have some subject, you probably want to bind it to a bunch of granular roles. Right? So in this case, this subject has policy, admin, and viewer across the cluster. Right? So say like this is like somebody on some team is the subject. And then there's role bindings for 3 different things in one namespace. It has update quota, port forward inside the namespace. And then also inside the namespace, we're using a cluster role called route editor, just so that we don't have to redefine ourselves all the time, right? And so you can role bind multiple times to the same subject. You can also role bind multiple subjects and use a mixture of roles and cluster roles to get very granular access to the things that you should have access to do your job. Another misconception is that since service accounts live in some namespace, that apps can only access things inside of their own namespace, which is not right. You can have an app in a different namespace because an app is just a user. It's just a special kind of user that has a token next to it. And so if you have an app in another namespace, say my dev team wants to work with an app from other team, we've got something inside of our namespace that their app needs access to. Say it's a config map that we produce for them. That app is part of a service account group inside of its own namespace, and we can bind to it from our namespace to give them access to our things. So another huge misconception. You can role bind to multiple subjects, but only one role. Something you don't see happen a lot, but it would really simplify your configs if you just have, like, say, all of the admins for a namespace, they're just part of one role binding. If the same person is managing the role binding, you might as well have them all listed in one place. Service accounts are just users. There's nothing special, like cryptographically or anything happening. The Kubernetes API will figure out how to authenticate the application. There's a bunch of stuff with the kubelet and each pod getting its own token and stuff, but at the end of the day, once the app is authenticated with the cluster, you can actually also just provide access to a service account with its username. It's part of this system service account prefix, which is reserved inside of Kubernetes. It has the namespace and the name of the account. Service accounts get groups. I never see anybody use these things. They're so powerful because then you don't have to bind your configs in one namespace to something that somebody else controls. You can just say everything from the other namespace gets access. I don't own it. And so there's system service accounts, which is every service account in the cluster, and then there's also the system service accounts namespace group for each namespace. Use those. Those are very useful, like such as this picture. Right? If my dev team doesn't control the name of the service account, then they probably shouldn't tightly couple their configs to a name from another namespace, right? Just use the group. There's a bunch of underused features. So once you're making a role, we can talk about like verbs and resources, but resource names are also useful if you're trying to get really granular, specific. Maybe you're in a very high security environment, or you have like a shell script that you put in a job that's just only ever supposed to update like one thing with a very specific name. I use this a lot, resource names. So this is an example from the upstream documentation, a role for an application probably called config map updater. Something is going to role bind to this to give an application access to update a config map, but only the one called my config map. And it cannot create, it can't patch, it can only do an update and a get. Create, it does work with resource names. I know I just spent a whole slide saying like I use this a lot and this is really great. This is a weird limitation, which I'll also talk about in the limitations section. This only works if you're using server-side apply, which is not on by default right now. If you're using something like Flux, it always is on. But the create verb only works to actually create something if you use SSA. If you're not using SSA, it's not going to function. There's this feature called cluster role aggregation. Basically, the best way to explain this is to actually look at a config from a working cluster again. So here is that viewer role, or I should say view role, right? If I go into a default kind Kubernetes cluster, then I can get the cluster roles. You can see that there's a bunch of granular access set up here, a lot of different roles that people can be bound to inside of a Kubernetes cluster. Also a bunch of things that have been added by like things like add-ons. I have like cert manager and linkerd installed. But let's just ignore all the system stuff. There is these are labeled actually. Maybe I should just query for this label. Hopefully I'm using kubectl right. Oh, all of those are default anyway. And then I filtered out cert manager and linkerd, and now let's get rid of all of these system things which are used for controllers. So these are the default cluster roles that are intended for, like, say, a platform admin. Wow, my terminal is, there we go. There's admin, cluster admin, edit, and view. These are cluster roles. They describe namespaceable objects. They describe all of the cluster reachable objects as well. But if you bind to these with a role binding from a namespace, they're super useful, because then you could, like, give somebody view access only to one namespace, or edit access to 3 namespaces. And then you could also give them view across the entire cluster, right? So cluster admin across the entire cluster, you know, a lot of people get that when they first set up Kubernetes, but how many times do you really need to work on the entire cluster, right? We're usually doing one specific thing. So this is how you can start to build more granular access control. And the way that these roles are built up is actually really, really cool. So view is the most basic role available. It's the most granular, right? We can only view a certain number of types of objects. We can't update anything. If you give somebody view access, you're pretty sure that they're not going to be able to get anything secretive or important out of your cluster, and they won't be able to damage anything. The view cluster role has an aggregation rule. That seems interesting, right? And aggregation rules, you can see the doc strings are really good. I'm struggling to not read my autocomplete. Aggregation rules have this cluster role selector that matches labels. It's a label selector, similar to, like, deployments or replica sets or something. This label selector says that anything that is labeled aggregate to view is going to be sucked up into this role as well. And it's, again, something I see a lot of people not use. In fact, when I installed Cert Manager on this cluster, it added its own API group to this role instead of using cluster role aggregation. Let me show you how it works. You can, say you have an add-on that adds an API to the cluster. You can make a small list of rules for just your add-on's API group. And then you just label it. You say, hey, this thing should be aggregated to view. Now all of this stuff gets added to the view role, right? So a really underused feature there. There is a bunch of sub-resources. This is a non-exhaustive list, but you can see some interesting things in here are like proxying to nodes, finalizing namespaces, port forwarding on pods, getting the status of various resources. These sub-resources have actual routes in the Kubernetes API. You can give people access to just verbs on these sub-resources without actually, you know, giving them access to pods or giving them access to nodes. And so that's really helpful. Lastly, there's like these weird virtual verbs. One of these in particular is very close to my heart. It's called impersonate. Binding and escalating are also things that you can use to kind of create pseudo access, either for some app or if you want to, like, write some sort of pseudo tool that gives people access to assume roles of other people. And I will show you why impersonation is useful. Now that we've talked about cluster role aggregation and impersonation, I'll show you how they can be used inside of a cluster. So just go check my namespaces here. So you can see that we have this team1 namespace. There's also a bunch of other stuff in the cluster. Linkerd is installed, Cert Manager is installed, Flagger is installed, Flux is installed. But in the team, oh, sorry. No. Yeah. That just happened, right? Yeah. Cool. I do understand that talking about any Kubernetes API and any level of complexity does tend to be kind of offensive, you know? Like, it's just, we seem to all be a little obsessed with computers these days, and like, Now we get to look at this other part of the computer. I didn't click anything. I could try turning off present and then
run the mic and get a question out of it.
cool. Okay. Yeah, does anyone have any questions? I mean,
I have a question.
Yeah, what's up, Gwen?
So when I try to grant access in my cluster, often the API tells me, you can't grant this access. How do I get around that?
That's actually a really good question. It almost is like it's a leading question. I'm already mic'd up.
Oh, you are? Yeah, I forgot.
So, yeah, this one is cool. You cannot grant access to things that you don't have access to. When you say it out loud, simply, it makes sense. But when you're committing a YAML file to a cluster that has a bunch of resources in it, and then it complains to you saying that there's a bunch of RBAC errors related to it, sometimes it can be a little bit confusing. So what's cool about this is to actually think about it in what it lets you do. Say you give a team access to a namespace. You give them an admin. So you role bind their group in GitHub or in Google. You give that group admin to a namespace. That group can give another team view to the namespace. But that group cannot give cluster admin to another group in that namespace because they don't have the full scope of cluster admin themselves. And it's pretty amazing the API server is able to do these validations because it does it at a very granular level. It's not whether or not some object exists. It's like it checks each and every line item that you're trying to grant access for. So yeah, does that sort of address the question?
Yeah, cool,
Sweet.
thanks.
Cool.
Is this still on? Yes. Any other questions? Please ask questions.
Yeah, just wondering, can you talk a little bit about how the implementation of RBAC, I mean, like the data structure, or especially if there's any limitation that we need to be aware of in terms of performance?
Maybe not in terms of performance so much. This stuff is all built into the API server, so it's incredibly fast, and it's calculated, on every change. There is like always going to be a latency. So like when you put an RBAC, like say you make a role binding, it's impossible for that role binding to be effective immediately. And there's actually not a lot of documentation about this. But what we do is we just trust the API server so much that in like milliseconds, it starts to work on making sure that any new requests that go to those API servers, they don't like violate the rules that have been committed to the API. And as far as actually implementing, I have some slides on this. It sounds like you want to hear about some gotchas, so I can actually talk about these limitations, and then I'll go back to this demo. List and watch, they allow getting every object. So say you are implementing this in your organization, kind of like what you're asking about. You want to be really careful giving people list and watch if you're not trying to give them get. So if you only want to give them get to certain objects, but you want them to be able to list everything, listing actually gives them every single object already. So that's a limitation. You cannot really filter lists. You can't use resource names to filter lists. This is problematic. Like say if you want to share a cluster and you want people to see the namespaces except for this secret one. So there's other solutions to that. You can use something like a V cluster, a virtual cluster that virtualizes the Kubernetes API into multiple Kubernetes clusters, even though there's only one. There's also a filtering proxy called Clastix that you could look at that can do that. So with RBAC and your teams, when you're actually implementing things, you're going to need a way for Kubernetes to know who your users and groups are. And Kubernetes doesn't do this by default because it's an open project that's not coupled to any one implementation. So if you're using a managed Kubernetes cluster in your cloud, it's likely that your cluster understands identity resources from your cloud, right? If you have like SSO enabled with AWS and you're using Elastic Kubernetes service, it probably is going to know who your people are if they log into Kubernetes through the AWS APIs. But a default Kubernetes cluster knows nothing about who the people in the room are. And so you do need some sort of integration with an identity provider that happens in the infrastructure of how you set up your cluster. There are some like built-in mechanisms that Kubernetes uses internally for identifying things, right? Like we have a bunch of controllers and apps inside the cluster that all need to work and have privilege to talk to itself. But those are really for things inside the cluster. They're not for people. I don't recommend using service accounts outside the cluster because they're for their apps. They're supposed to be local to the compute. If you have multiple clusters, service accounts are not valid in another cluster. They shouldn't be used that way. Certificate auth, the reason why I steer people away from it is usually you already have another identification provider. And certs are hard to deal with if you don't already have a certificate authority and a bunch of other things, and there's revocation problems. It's just a lot to handle, and it's very low level. You need a better solution than this if you want to do real work with people. Maybe it's fine if you need like 2 certificates to access like a Raspberry Pi and 3 stores or something. But otherwise, I would integrate with an identity provider. And that's what allows Kubernetes to understand the users and groups in your organization itself. If you don't have a good way of integrating with things, just like using like the command line flags from the API server and a bunch of other low-level Kubernetes parts, you can just install this project, which I really recommend, called Pinniped, that allows you to hook up to like Active Directory or SAML or GitHub authentication or some OIDC provider. And Dex is also really cool, but if you actually mix Dex and Pinniped together, you get like the greater sum of both parts. What's really different about Pinniped is it works on any Kubernetes cluster. So like even if you're in some cloud provider, you don't need to like use cloud provider APIs to configure identity. And you like don't have to have access to the control plane infrastructure, which often in like a managed Kubernetes cluster, you have like no access to that. So it's just a really generic solution that can be completely configured from inside the cluster. Underneath, it uses certificates and a bunch of things to like rotate your token, and there's like a helper on the command line side for kubectl. But that's an implementation detail. Hopefully that kind of helps address what you're asking about. Hopefully I didn't ramble on too much for that question. Other recommendations I can make are to use the Bootstrap cluster roles. So the Bootstrap cluster roles are those default ones that I was showing you in the terminal, which was basically all of these. This filter. Yeah, so admin, cluster admin, edit, and view. You should use your groups. If you are doing a lot of bindings to individual persons, then that's a sign that you might not be able to really deal with organizational change. So like, as your people move on and you like hire new people and stuff, you're gonna need to be doing a lot of onboarding. If you could just put people into groups, chances are they already need access to a bunch of other things like Git repositories and documentation and some support application and a service desk and all those things. Use the same groups you use for that stuff to give people access to the compute inside of your big distributed computer that does all the important things. In OIDC, this is called the groups claim if you're trying to figure out if your identity provider supports it. Our tools really are critical to the way that our habits work. So before I talk about GitOps, I'm going to do that demo that we were in the middle of. Right? Let's check my time here. So we have a namespace, right? The namespace is called Team1. If we, as the cluster administrator, look inside of the Team1 namespace, just no typos, then you can see there's some pods that come from the replica set managed by this deployment. It's just Nginx. There's also a config map in here that I think I put in there earlier. Yeah, here's a certificate. There's the Linkerd trust, and then there's a README that just has some documentation about what the team is doing inside of this cluster. So I'm the platform person, right? I got access to this cluster, and I was just sitting down with Daniel and Sarah from Team1, right? And they're like, yeah, okay, well, our app, like, we figured out how to build a container, and we pushed it to the registry. And I was like, yeah, dude, I got this. I know how to use Kubernetes. I'm going to set up your namespace. I got the cluster access. I'll get you all running, and I'll set up. And so Daniel and Sarah are like stoked. They're like, cool, Leigh's helping us out. But I want to enable them, right? Because they're smart people. We're all learning a little bit about Kubernetes already. They just built their first container and they pushed it to the registry. They can see the manifest in the repo because I'm using GitOps. But when something goes wrong, you know, and like somebody accidentally drops a table, they're going to need access to the cluster to go and look at what their application is saying. Maybe they want to read some logs. Maybe they want to see if something is crashing. Maybe they want to restart something. I'm going to give them admin access to this namespace. As long as I restrict them to just this namespace, they're not going to hurt anything else, right? They're not going to mess up my Linkerd installation. They're not going to mess up Cert Manager. I know everything is reconciling based off of what is in Git because Flux is installed. It's cool. I'm the platform admin. But I'm not trying to hamper folks. And so we can use kubectl impersonate. It is a kubectl auth, can I. So let's say get a deployment as anyone, because the username doesn't matter. I want to use groups from, I think it's called as group my org team1 in their namespace. So kubectl auth, can I get deployments as anyone from this group in this namespace? And it says no. No. So, but if I wasn't impersonating anyone, which I just have to take out the as group and this is me. I can do that, right? I can do anything because I'm cluster admin. So let's go ahead and fix that, right? Here I have a file. It's a role binding called Team1 admins. Here I can have a list of subjects. I'm going to add their group, kind group from the RBAC API, my org :team1. I think that's what I typed, right? Yeah. Right. So this group, I want to bind them to the admin cluster role. But even though I'm using a cluster role, right, which talks about a bunch of cluster stuff across the whole, you know, there's a bunch of objects you might change. I'm only going to do that in the Team1 namespace with a role binding, right? So this is not a cluster role binding. I just want to give them the one namespace. So this file is called Team1 admins. Should be in the bindings folder, Team1 admins. Kubectl apply. It's a declarative file that I can create and delete, but it's like tracked in Git, you know. So now that that's created, if I go ask that question again, kubectl auth, can I get deployments as anyone from the my org team1 team in the Team1 namespace? Yes. There you go, right? But, oh, and then let's keep those flags and that namespace and get deploy. So if that's possible, I can impersonate them, right? I can say kubectl get deploy as anyone from that group, and you can see that it actually works, right? So I can ask the question from the RBAC system, will it allow it? And then I can actually go and do that thing. And the ability to ask the question before you actually go and do the thing is less consequential when you're getting a bunch of resources, unless maybe there's like 1,000 and it takes a while. But when you're creating and patching and updating things, for instance, like I don't have to create anything, but maybe now I don't want to get the deployment. Can I delete the deploy? Sure. It's their app, right? They probably have a good reason if they need to do that. So now team 1 is the administrator of this namespace. But when they walk into this cluster, say I impersonate them. Instead of doing anything namespace or whatever, say that somebody is new to the team and they're just lost, and they just walk up to the cluster and they're like, okay, what namespaces are in this cluster? Well, they're blind. They can't really see anything, right? So maybe I should go and fix that. Say that they are in the Kube viewers group as well. Well, if I cluster role bind the view role across the cluster for this group, right? Or we'll just say team 1, right? So these are all the Kube viewers for across the cluster, and one of the subject is going to be team 1. I could add like other teams here too. Why not? Cool. Then team 1 and team 2, they're going to have view access across the cluster. Let's go ahead and do our apply, but instead of team 1 admins, it's going to be the Kube viewers. So now, when I try to get namespaces as anyone from that team, I was very confident and bold. It works, So now people can actually see namespaces. Somebody can see, oh, Linkerd is installed in this cluster, cert manager is there, but I don't have admin access to all those other namespaces. I can't change anything, but I'm empowered with knowledge. I'm empowered with the ability to discover what is happening inside of our infrastructure without the ability to change anything or even see secrets, right? I cannot see the secrets across the cluster, only stuff from my own namespace, right? So this is a great example of how you can empower a team as a platform administrator. I have a bunch of privileges, honestly kind of even scary. I should probably give myself some role that's less powerful that I'm using most of the time. But when you need to break glass, you can impersonate. Right? You can check who has access to what, and then you can be certain that the experience that somebody's going to have is going to enable them to do their job. Right? Make sense? Cool. Sweet. All right. So there are some other limitations that I skipped over. You can't filter lists. We talked about vClusters maybe. Resource names and the create verb, we mentioned this earlier. It only works with server-side apply. If you're hitting this limitation, though, maybe you can also just put that thing in another namespace. You can always make another folder. There is a controller called hierarchical namespace controller. If you have like a really deep organization where like your manager has a manager and a manager and a manager, and then also this manager actually has 2 teams, and then this org just split, and like sometimes it might be good to mirror the hierarchy of what's happening inside your compute. With namespaces, there's a controller for that you can install. We talked about some of the recommendations of hooking up your cluster, integrating with users and groups from outside of the cluster, how you might do that if you're using an on-premises upstream Kubernetes cluster instead of a managed solution, and using the bootstrap roles, which we just did, right? We bound to a bunch of groups. And so now we have to think, okay, well, if this is going to be the way that we share the computer, then how do we onboard people and how do we enable people to have transparency about who has access to what, right? More than just what you have access to yourself. In a successful DevOps culture, like we've learned over the past 10 years, you need to be able to give people information, transparency, and self-service access. So, say you're the platform team and you have a control repo. I would really recommend that all of these manifests, right? Like I got a bunch of folders right now. This is not in a Git repo. I should probably put this in a Git repository. I should probably version this information because this is the information that tells the computer and everybody else who wants to know things about it that the admins for the team 1 namespace is only that team. Does anybody else have access to that namespace? We should probably list them here, right? The viewers across the cluster are these teams. This is very valuable intellectual property, This is not like cool algorithms. This is not like sorting in a for loop and all of this cool stuff. It's not securing APIs. It's not using a service mesh. It's not technology. This is information about your organization. This is how we get work done. If we want to move into a different cloud, if we want to change our infrastructure away from Kubernetes completely, our team is probably still going to work this way. And so I would really encourage, if you are trying to wrangle access in your organization, get your onboarding process, the way that your org changes the way it works, the way that it handles emergencies and access to compute, into a control repository so that you have process for protecting and changing these configurations. Maybe, people shouldn't have access to just change all of this stuff themselves, but they should be able to open a pull request when they get a new team member, right? So, yeah, you can write integration tests using that impersonation thing, right? So kubectl auth can I. Say that you have some manifest that's like, these groups should be able to do these things, these groups should be able to do these things. You can actually check and run that against your cluster regularly, show the build log output to somebody, say, hey, this is the experience that you should have. Do you want to add a test here to make sure that you always have access to the thing you need? Write an integration test. And then, yeah, that's pretty much kind of the summation of my recommendations. The whole point is, let's go all the way back to this. This slide. So with all of the details, all of the limitations, we're trying to share the computer, right? We don't just use one laptop at our job anymore. We have a bunch of computers in a data center. Maybe it's running Kubernetes. We're trying to deploy many applications, stand up networks, support new clients, reach our users, transform data, add value, make money for investors. Subject and role, who and what, and the role binding. That's how we answer the question of, can I get access? So my name's Leigh. You can follow me in a bunch of places. And reach out to me, my DMs are open. That's my GitHub. And we got like no time for questions, but it's lunch. So, yeah. Yeah.
Wait a second, there it is. Any questions? I'm going to run the mic to you because we are still recording this, so please wait for the mic.
Hey, thanks for the awesome presentation.
Thanks for the feedback. Yeah.
We are making a move from a Tanzu VMware shop to an EKS AWS native. The mission control made a lot of this easier to build these policies and implement and enforce these RBACs. Is there a prescriptive template out there that one can kind of look at in a matrix way to look at verbs, objects, access, and kind of start to build your own RBAC matrix? Every organization is different, needs are different. More than likely the platform engineering versus dev controls and access to namespaces and limitations are pretty. I think that was cue for me. That was a long question.
That's all the locals, their Amber Alert probably, is there flooding, is that? All right.
I think as more organizations are GitOpsing their access controls, right, we'll continue to have those stories. And it's a little bit hard to find examples of people like just posting their intellectual property, right? And access controls are like a huge part of that, especially if you like, from a hacking social engineering perspective, right? And so is there a template? I would love to see one, right? Maybe I should work on more of those kinds of things, right? That not just like a hello world, but something a little bit more fleshed out,
We'll do one more quick question, and I know Leigh's going to be around, so you can ask some questions out in the hallway if needed.
Hi, thank you for the presentation. I was wondering, so we have the impersonate verb, Now, if I want to allow someone to impersonate someone else,
Yes.
how do I role bind that?
The impersonate verb should be always restricted with resource names. So you can say, you give somebody the access to impersonate a resource name, which is actually a user or a group. So you can impersonate a user, you can impersonate a group, you can impersonate a service account.
So the resource would be the subject in this case?
Yes, yeah. Mm-hmm.
Thank you.
Does that make sense a little bit?
Yeah.
Cool. Yeah, and definitely restricted with resource names, because if you're giving people impersonate access, then they can like impersonate the kube controller manager, you know, or something dangerous like that. There's also bind, which allows people to like temporarily bind themselves to like another role, and you can also restrict that with usernames, or resource names. Yeah, thanks for the question. That's a good one.